Mr. Here, and here we're going to go over precision and measurement here. So, first of all, we have to define what precision is. Precision is the degree in which repeatable measurements undergo conditions showing the same results. You have to have multiple measurements to determine precision. If you do not have multiple measurements, you cannot determine precision. Oh, the camera's over there. I'm trying to get used to my new setup here, and I can't stretch the camera over here like I used to, so I have to stretch the camera over there. So, whatever. Notice we have 5 shots on each one of these, right? Okay. This first one, we're going to talk about accuracy and precision. So if you average all these shots, you would say that this is accurate. But this shot is far away from that shot on the top, so this is not precise. Okay, the accuracy on this one, not accurate at all, so I would call this inaccurate, because the average is not close to the center. And the measurement, this measurement's far away from that one, so I would call this imprecise. That's the worst one. You don't want that one. Here's the ideal one. Look, if you average all those shots, you get the center. That's accurate. And I can't spell accurate. Awesome. And it is also precise. Okay. Oh, I misspelled precise over there too. Wonderful. I'm doing great this day here. You know, I'm making this video in the middle of July. Yeah, that's how dedicated I am to you. Now this one, not accurate. But the shots are close together, so this is precise. So if I was ranking these, this is the first one I would want. That's the goal. This would be the second, because all I would have to do is aim you towards the center and you would be accurate and precise. This would be the third, and I would have to teach you how to be precise. And this would be the fourth. That's the worst one, and I would have to teach you everything. Okay, the term of precision, it can also be used for glassware. The closer the range of markings for a particular glassware, the more precise the piece of equipment is. Okay, so this one has no markings because it's a test tube. This one has 50 milliliter markings. This one also has 50 milliliter markings. And this one, it looks like it has 1 milliliter markings. So this is the most precise. This is the least precise. Okay. Nobody uses test tubes, Erlenmeyer flask, or beakers to measure. We always use graduated cylinders, graduated pipettes, burettes, or volumetric flask. Watch out for the volumetric flask. Volumetric flask are always precise. Even though it has one line, it's like 25.00, that line. So watch out for those volumetric flasks. That's where I'm going to try to trick you. Volumetric flasks are very, very precise. On to page 9. Page 9. Page 9. Okay. Because different pieces of equipment have different levels of precision, we cannot report the quantitative results the same every time. We use the concept of significant figures, which we will learn in Chapter 7, second semester, to determine how many digits are appropriate to report. You always report one known digit plus one uncertain digit. This is the estimated digit. There is always one estimated digit when you make a measurement. Okay? If the measurement is on the line, you must add a 0. The 0 of the measurement tells me it is on the line. On the line. Okay. Not reporting measurements with the correct amount of significant figures and with units Can cost you points in the lab. It's the first thing I check. It's the easiest thing to check. That's why I check it first. Also be aware of the glassware, the curvature of the liquid, referred to as the meniscus. And you measure at the bottom here. Okay. Read the following ruler and glassware to the correct number of significant figures. Okay. So first of all, this ruler goes by tenths here. So you can see this is 0.1, 0.2, 0.3, 0.4, 0.5, right? So the markings are 0.1 centimeters. Which means you must measure to the hundredths place. Every measurement I'm going to write down is going to be to the hundredths place. So if I'm looking at point A, let's say if I'm doing point A is between the lines. Okay, so it's between 0.5 and 0.6. It's closer to 0.5, so I'm going to put down 0.52 centimeters. Okay, now if you put down 0.51, I would actually mark that correct. And I'll explain why in a second. Point B, that also looks between the lines. You estimate between the lines. This is 0.7, this is 0.8, so this must be 0.79 centimeters. Okay. C is also between the lines. This is 1.5, this is 1.6, it looks closer to 1.5, so we will say this is between. So this is 1.58 centimeters. Give me a second to look at that and write that down. Now we get to D. D is on the line. On the line. Okay. What line is it on? 2.5. So this is 2.50 centimeters because it is on the line. E, also on the line. What line is it on? Well, it looks like 3.3. So it is 3.30 centimeters. Remember that 0 tells me it is on the line. And then F, oh, that one's between the lines. This is 3.6, 3.7, and let's go with 3.67. If you wrote down 3.68, I'll mark that correct. If you wrote down 3.69, I'll mark that correct because you estimated between the lines. Notice that all these measurements, 0.52, 0.79, 1.58, 2.50, 3.30, and 3.67 are all to the hundredths place because this ruler can measure to the hundredths place. Okay, graduated cylinders here. Again, we got to figure out what these are going by. So this is 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So the markings are to 1 milliliter. Each line represents 1 milliliter. So here we are going to measure to the tenths place because we have to be able to estimate between the lines. So first we're going to do A. A looks between the lines here, so this is 37 and this is 38. Not on the line, so we're going to say that is 37.8 milliliters. B is on the line. It is on the 35 line. So this is 35.0 milliliters. You would subtract the 2 and you would have a difference of 2.8 milliliters you poured. Okay. Notice again, when I measure here, all my measurements are to the tenths place. You have to write the 0 because it is on the line. Because if you don't write that 0, I assume it's not on the line, and I assume we have a different graduated cylinder that is marked by tenths. Okay. The burette. Okay. The burette's upside down. Remember that the burette is very precise. Okay? It doesn't matter how much you put in the burette, it matters how much you get out. So it usually has a layer up to here. There's a stopcock down here that pours out the liquid, and the liquid goes down, and then you know the difference between there. Okay? This burette is marked 10, 11, 12, 13, 14, so every line is 1 milliliter. So we will measure to the tenths place. Okay? So we're going to do the final volume first. Usually in chemistry and physics, you're going to do final minus initial if you have to do subtractions. This is between the line. Now notice that 10 is here and 20 is here. So this is actually 18 here and that is 19 there. That looks like 18.4 milliliters to me. If you wrote down 18.3, again, I couldn't question you because you actually measured to the tenths place. Now we're going to do the volume initial. This one is on the line. Well, it looks like it's on the 15 line. So we're going to put 15.0 milliliters, and you subtract the 2, and 3.4 milliliters is what came out of the stopcock and into your flask. So this will be 3.4 milliliters. Okay, you guys are champions. The legend is out.